Hi guys, so today we are going to explain ELLINGHAM diagram. We all know in the extraction of metal, first the metal is concentrated, then it is extracted. During the extraction, first the metal is oxidized to the metal oxide using roasting or calcination. After that process, the metal used to be reduced into the metal itself in the pure form. But usually the most of the metal reductions are non-spontaneous or their delta G value is greater than 0, but we need delta G less than 0, as only delta G less than 0 process, that is, if delta G is negative, the process will be spontaneous. Only spontaneous process will be carried out in this reduction process. So we couple another reaction with this reaction, that is, we couple first reaction and second reaction, where delta G1 is the reduction of metal and delta G2 is the oxidation of the reducing agent. Here reducing agent we particularly mean coke or the carbon and the carbon monoxide. As you all know, it can reduce most of the metal oxides like iron oxide, hematite, magnetite, etc. I am making this video particularly for all those students who are a lot confused with the graphs related to ELLINGHAM diagram and the theory behind it. So today we will unite the theory and the graph. So we know that sum of the spontaneity should be less than 0 or delta G value should be less than 0, only then the process can be spontaneous. So here we can see that delta G1 plus delta G2 should be less than 0, or rearranging, the oxidation delta G2 should be less than the opposite of the reaction, that is oxidation of the metal. So by reversing the graph we can see that the delta G1, negative delta G1, the negative delta G1 is the oxidation of the metal which we see in the graph, and below it we can see the reducing agent, that is the delta G2. So thereby we reach the conclusion lower one can reduce the above metal oxide. This is the principle of ELLINGHAM diagram. Thereby we say that the lower one can reduce the upper one. So by recapping on a quick review,